Alright, our first trial. Water is at full saturation. We're going to introduce a current of 5 volts. Yep.
See if there's any reaction in the undissolved salts on the bottom of the solution.
Voltage is at 5 and holding. Precipitate at the bottom of the beaker has remained the same. The output, or the negative side, is bubbling.
Yeah, the anode. I will have to look it up. But what is interesting to note is that, well, that would be the negative side, right?
Yeah.
So that would be calcium building up on there?
I'd imagine. These are galvanized nails.
Yeah. So they're covered in zinc. So this could be the zinc reacting with our salts.
So now we're going to try adding 5% more salts to the solution. Okay, do you have
So 0.5 grams. And the stir stick is just over there.
I wanted that to be a U, but just
Now, with the potential difference, what should be happening is a current of calcium ions, maybe even sulfates, going from one end of the circuit to the other end. We'll probably see
It seems as though there's no precipitate on the bottom anymore, or at least the same amount since we added the salts. However, the water's still moving, can't be sure. Okay, adding another 5% of calcium sulfate to the mix.
let's not 5% anymore.
Okay, 5% of the initial.
Yeah.
We've got to build a precipitate in the middle of the beaker.
Touch that all with your finger. No, there's little clumps right there on the bottom, so it would be really easy to watch them dissolve if they do dissolve as we increase voltage. So, want to try that?
Sure. Increased voltage by 5, so we're doubling the voltage now.
Voltage is at 10 volts. Appears to be no change, but there is an increasing vigor in the reaction on the one nail. In fact, it was bubbling, and it looks like it's turning black in places.
Oh,
What?
it's giving off a powder too into the water.
So it's precipitating?
Yeah.
So that would indicate that the zinc is actually reacting with our solution.
hope she got fired.
I don't get a chance to see your observations. Come on,
And no change to precipitate in the bottom, but no, we're not sure if that's the precipitate from the nail or the precipitate from our salt. Or the precipitate is the salt or not.
blemishes on the other nail appear to be more exaggerated.
Blemishes?
The teacher did?
Yeah, I can see some discoloration on the other nail actually.
Just gonna try and stir up the precipitate, see what happens. Do you want to increase the voltage?
Yes.
15?
Yeah, it's way up there. Like less. 15 volts.
The negative is giving off a lot of precipitate now.
Something interesting to notice, positive on these kinds of machines usually refers to the electrons building up on that side and then going through the circuit, right? So if zinc was ionizing in the nail, it would be a positive ion, correct? So because of the flow of electrons from this from this nail to that nail, then the positive ions from this nail are coming back into the solution.
We seem to have the same minimal precipitate at the bottom as before.
So it would be important to test this without galvanized nails.
Well, let's finish this one then. Put it up to 20 volts.
That is one angry nail.
And we'll max it out to 25 volts. It's funny that one nail's reacting so violently and the other one appears to have no reaction.
But even though it appears to have no reaction, there's probably a buildup of zinc on it now. That'll be interesting to note the difference in appearance of the nails.
I want to give it one full minute.
Yeah.
Okay.
Question that stirs Rosette.
Seems pretty dizzying to watch over there.
It's a new sound for signals. It doesn't
It's a lot of precipitate coming off now. It's hitting the top of the solution and starting to cause water to be excited and move around.
Precipitate at the bottom of the solution remains unchanged, but if we stir it up to the point that it gets caught in the current between the nails, that could cause more of it to dissolve.
It seems like less precipitate to me. We'll have to measure.
We can store this.
I just said for RV.
Okay.
Doesn't even make any sense.
Okay, point.
No, not even
186. 264.
I don't know. I have it for grade 10. I have it for grade 10. And it's like
All right, 10 seconds.
grade 10.
The solution's pretty discolored again. And there we go.
What do you mean, errors?
Voltage removed.
Copied them?
Let's see what the nails look like.
Can you get it out of there without
Mess something up.
Nope.
Let go.
I got it.
Okay. So this one coming from the positive output.
Glasses for the same reason I don't like.
It looks relatively unchanged. The ridges on the edges of the nail are still there.
Okay.
It's like a standard nail.
Second nail. The one that was evidently more reactive. Have to pour the solution out probably. If you want to do it.
Most people are like that. I've just got so used to it. I can do anything. I use it. Okay.